Okay, this video is going to cover the next part of Unit 2, 2.4 complex numbers. This one shouldn't be too bad. It just might be a little bit new. Okay, so recall, if you didn't know this you might want to write this down for sure, that the imaginary number I, so I stands for imaginary number, is defined as the square root of -1. Okay, so whenever we have a negative inside the square root, usually we get like an error or some kind of message that says there's a mistake. So what we did as mathematicians is we created kind of like another number system where we can take into account those numbers. So this number is called the imaginary number I. Okay, and this leads right into the fact that I squared would be equal to -1, since if you square both sides right here, you get I squared and -1, okay? So when we combine these numbers, imaginary numbers, with the real numbers, we actually get this whole new set of complex numbers. It looks kind of like a C. It's like a C with like a little line, vertical line going through it. Remember that the ones that we're used to using are the reals, which you're going to see in a bit, which is pretty much everything you can think of it like this dimension. Complex numbers are a combination of that. So complex are reals and imaginaries put together. Okay, so here we go. Here's our official, I guess you can say, definition for complex numbers. We have if A and B are real numbers, but I'm going to use shorter notation from now on, then the standard form of a complex number is going to look like this: A plus BI, where the A, so the first number or the number that doesn't have an I with it, is our real number, and then this B goes with the imaginary number, okay? We have a few cases when B is equal to 0, so if this is equal to 0, it's pretty much gone, so it would be kind of like just the A. This would just be a real number because, well, there's no imaginary part, because 0 times anything is just 0, okay? And when A equals 0, but B does not equal 0, so now we're covering the A, all we're left with is BI. This would be an imaginary number. And if we do have anything of that form where it's just BI and B is not equal to 0, this is called a pure imaginary number because it only has the imaginary part. Okay, so we're going to go ahead and just do a few quick examples just to kind of identify what's what. Okay, we have determine whether real or imaginary. So I'm going to go ahead and just quickly color code a couple things here, or several things I should say. For letter A, I'm going to go ahead and do all my reals in red. So I'm just going to do all of them. So this one doesn't have one, okay? And this one. So it looks like all of those have a real part of their number. And the imaginary parts I'm going to do in purple. So that one is 3, this one is 0, this one is 2, this is -3. Okay, so with that in mind, I can go ahead and kind of sort of identify. So I'm going to do a little bit further. Here I'm going to say that my A is equal to 2. My A for this one is equal to 7. My A for this one is equal to 0 because there is no A. And my A for this one is equal to 3. Great. I'm going to do the same with the imaginary numbers. So the B, okay, remember that's BI, is equal to 3 in this one. The B is equal to 0 in this one. B is equal to 2 for C, and B is equal to -3 for letter D. Okay, so now we can kind of decide whether or not these are real or imaginary. For letter A, since we have both parts, it's going to be imaginary. Okay. For letter B, since B is equal to 0, okay, it's really not there because 0 times anything is 0, so this one is going to be a real number. For letter C, we can see that A is equal to 0 and B is not equal to 0. In other words, we have a value for B, so this is going to be a pure imaginary number. Okay, and last but not least, we have letter D, which has both parts with a number that are not equal to 0, so this is going to just be an imaginary number. Okay, simple as that. Moving on. Okay, so now we have the definition of equality of complex numbers. So we say that two complex numbers, and we have the form that we had on the other side, and another one, c plus di, are equal if and only if, okay, this notation here means if and only if, so we're going to start using that one as well. A equals c and b equals d. In other words, let me try to match this a little bit. So this number is equal to this number, okay? And the other number is equal to the other number. So this number is equal to this number, okay? So we're going to go ahead and do a few examples just to kind of show how that works. Example number 2 says find the values of A and B to make the statements true. The first one is kind of easy. If we look at the same color coordination that I did earlier, we have our A here. Remember, this is our real part. It looks like this is the real part. So right away, I can tell that A is equal to 7. I don't have to do any calculations for that one, okay? And the B is something similar. So there's my B, and it looks like the B on this side is -3. So B equals -3. No calculations required for this one, okay? For the next one, it looks like we have a combination here of numbers. So what we're going to do is kind of set stuff equal to each other here. Okay, I have my A part right here, A minus 2, and then I have the A part over here is going to be 6. So for that one, I'm going to have to set up a little equation kind of. I'm going to do, I'll do it right here. A minus 2 equals 6, okay? And then we just solve. So we add 2 to both sides. So A is equal to 8. And that makes sense because if I put an 8 right here, 8 minus 2 will give me that 6. And then we do the same thing with B, but now we're going to match it up to, well, the imaginary part, which is going to be this 5 right here. So same thing, B plus 1 is equal to 5. We solve. So B is equal to 4. And if we plug in a 4, 4 plus 1 is equal to 5. Okay, and the I is just, it's already there, so we don't have to do anything with that. Easy as that. Moving on. So far, I hope this isn't too bad. Okay, now we have adding and subtracting complex numbers. So when we add and subtract of this form, so same form as before, written in standard form, the sum and the difference are as follows. The sum is going to follow where we take our real parts. So you can see that the A here and the C here get combined, okay? Same thing with the difference. The A and the C get subtracted, okay? And the B and the D follow similar suit. So B and D will look like this. Notice that we pull the I out, kind of like factoring it out, okay? Same deal with the difference. Okay, so let's go ahead and do a couple of examples. This one again, this shouldn't be too bad. It's kind of like combining like terms. Okay, so same thing, same concept, except now we're dealing with i's instead of x's, and those i's stand for imaginary numbers. So let's look at letter A. We're adding 7 plus 3i plus 5 minus 4i. So I'm going to go ahead and underline my real part. Okay, so it looks like I have 7 plus 5. So I'm going to put that first. Okay, 7 plus 5 plus, I'll put this, I'll just do the numbers in red, okay? Plus, I'm going to put the other part in here. So according to what I have up here, the I is going to stay out here. And I'm going to just take the imaginary number that's next to it. So that's 3 and -4. So 3 minus 4. And you could say 3 plus -4, but that would be the same thing as 3 minus 4. Okay, so just don't get confused with that. And then, yeah, we just combine. So 7 plus 5 is 12. Okay, and we get plus 3 minus 4 is going to give us -1. So -1, and then we just bring down our I. Okay, and this looks a little bit weird, so I'm just going to write it a little bit nicer. So 12 plus negative gives me a minus I. And that is it. You might notice if you can kind of probably figure these out just by looking at them after a while. Um, 7 plus 5 is 12. 3i minus 4i is negative I. We just want to show you all the steps though, okay? Let's look at letter B. This one's a little bit more complicated. Okay, so here we're doing the same thing. We're going to go ahead and combine all of our reals. So we have 5 plus 3 minus 8. Okay, so 5 plus 3 minus 8 is the real part. And then we have, let's see, oh, wrong color. We have negative 3 plus 5 minus 2. Okay, so I'm going to add this, 1 second, plus negative 3 plus 5, that in parentheses, minus 2, and then the I stays on the outside. Another way to kind of do this, because in case you're getting lost with the parentheses and what's a minus and what's a plus, is just pretend it's an x, distribute and combine like terms. Okay, we can do that real quick again after just to kind of prove the point. So from here, we just combine everything. 5 plus 3 is 8. 8 minus 8 is going to be 0 in this case. So this comes out to 0. That's interesting. And then we get negative 3 plus 5 is going to give me 2. 2 minus 2 is 0. Okay, plus 0i. So it looks like this one is just, there's nothing there. Okay, this is just going to be equal to 0. Okay, and that is it for these two examples. We're going to go ahead and move on to, I believe, multiplication. Yes, we have multiplication next. So multiplying complex numbers. We have a few things here. Let me zoom out so you can see all of it. Okay, we have properties of the real numbers. Some of them, anyway, some properties are also valid for the complex numbers. So we have a few properties here. These are just the properties from like way back in the day when you first started mathematics, okay? And you can see that we have two binomial looking things here that if multiplied are going to give you the following, okay? So I'm going to go kind of step by step here. The first two things that you see here are distributive property where we're multiplying the A times C plus DI. So it's kind of like so, just can kind of follow along here. It's A times both of these. Okay, and that's the first parentheses right here, the first, you could say term. And then it's BI times C and DI. So that's the next one right here. And that's just your distributive property. Continuing the distributive property, we multiply this in, right? So it would be A times C, A times DI. And that gives us this line right here. Same thing with over here. So BI times C is going to be BCI. Okay, we tend to group the numbers together. So the B and the C would be together. Our imaginary stays on the outside. BI times DI is going to be BDI square. Okay, and remember I square has a special property. So on the next part, you can see that it's pretty much the same except for that I square. So recall that I square is equal to -1. And this is actually kind of a big deal, so make sure you remember this one. And then we use our commutative property where we just kind of group them a little bit a little easier, I should say. Here, AC comes down. BD times -1, so this part right here, okay, is the part that you see right here. So we just relocated it to the front to group it with our AC. These two guys just came down, so these two are just right here. And then our associative property, we went ahead and again moved a couple things and we put some parentheses here. So these two are just, that's going to be our real part. And then these two, I went ahead and took the I out and combined them like so and put them in parentheses as well. And this would be the imaginary part, okay? So this is kind of the process. It seems like a lot of work, but it's actually just FOIL. Okay, it's FOIL, step by step here. So we can use all of these when we're multiplying complex numbers as well. So we're going to go ahead and do that in some other examples. Example number 4, we have letter A, write in standard form. By the way, I don't know if I mentioned standard form. It's just the basic A plus BI. That's what we're trying to get to. Okay. So what I'm going to do in this one is I'm going to pretend it's kind of like an X, and I'm going to distribute. Okay. So that's going to give me negative 15 plus 10i, and it looks like there's nothing else to do for this one. So I am pretty much done. Okay, and if you wanted to be a little bit more specific, you can say that A is equal to negative 15, and I guess I should color code here, huh? And B, our imaginary part, is going to be equal to 10. So this 10 right here. Okay, next example, letter B. So letter B is an actual FOIL problem, so let's go ahead and do that. We're going to go ahead and do 2 times 3, and I'm going to just follow FOIL. I'm not going to do every single step how they did it up here. I think FOIL is a little bit more familiar, okay? So 2 times 3 is going to give us positive 6, okay? Then 2 times 3i is going to give us positive 6i, okay? And then we do the inside, so negative 4i times 3 is going to give us negative 12i, and negative 4i times positive 3i is going to be negative 12i squared. Okay, so make sure you understand that. So again, 2 times 3 is 6, 2 times 3i is 6i, negative 4i times 3 is negative 12i, and negative 4i times 3i is negative 12i squared. We're going to go ahead and regroup this so we know which part goes with which. And actually, before I even do that, let me combine these two here. So this would be 6 plus 6i minus 12i is going to give me, oh, I should have put, it's fine, I'll change it right now, minus 6i, okay? And then minus 12i squared. I'm going to change my I square into a negative 1, because remember that negative 1 is equal to I square. Okay, so let's rewrite that part. It's going to be negative 1 right here. I'm going to bring everything else down. So 6 minus 6i. Notice the change I made here, okay? That just looks weird to me. So minus 6i minus 12 times negative 1. Okay, we can multiply negative 12 and negative 1, so that's going to give me positive 12 here. Okay, bring everything down, and we're almost done. It looks like we can combine the 6 and the 12. So 6 plus 12 is 18 minus 6i, and we have reached our standard form, where A would be equal to 18 and B would be equal to negative 6, the real part and the imaginary part. Okay, not too bad, I hope. Last one, and I think that might be it for this video. It's going to be kind of a shorter video, and then we have complex conjugates, which isn't as bad as it sounds. So this one is 4 plus 2i squared. All we're going to do is expand this because the little 2 means that there's 2 of them. So 4 plus 2i times 4 plus 2i. Okay, and it's the same process, so we're going to go ahead and FOIL. 4 times 4 is 16. 4 times 2i is plus 8i. 2i times 4 is also 8i. 2i times 2i is plus 4i squared. Okay, let's go ahead and combine. So we have 16 plus these two together is 16i plus 4i squared. And I know you can probably do this step also. I'm just going step by step here. We can rewrite the I square as a -1. So bring everything else down. So 16 plus 16i plus 4 times -1. 4 times -1 is going to be -4. Okay, again, bring everything down. And it looks like I can combine the 16 and the 4. 16 minus 4 is 12. So 12 plus 16i. And we are done. We've reached our standard form. A is equal to 12, so the real part is equal to 12, and B, the imaginary part, is equal to 16. And I believe that that is it for this video.